Limit is y goes to 0, secant of y minus 1 over the tangent of y. The first thing we're going to do is try plugging a 0 in for each of the y's. That'll give us a secant of 0 minus 1 over the tangent of 0. The secant of 0 is 1 over the cosine of 0, which is a 1. 1 over 1 is a 1. So we have 1 minus 1 over the tangent of 0 is the sine of 0, which is 0, over the cosine of 0, which is 1. 0 over 1 is a 0. 1 minus 1 is 0 over 0, and we have the 0 over 0 indeterminate form. It's resulting from trig functions which are not matching each other. Neither expression is factorable in the numerator or denominator. Neither of them have a square on the trig function, so we don't have a Pythagorean identity. Neither of them have a 2y, so we don't have a double angle identity. The only thing that is left then is a trig conjugate method. Now, nicely, we do have a trig combination in the numerator involving secant of y subtracting another term, and so we can try multiplying the numerator and denominator by the trig conjugate of that trig combination. Now, the trig conjugate's the same expression, but opposite sign between the two terms. And we're going to put it over itself so that we multiply the entire thing by a form of 1, which doesn't change the value just to look. Whenever you multiply by a trig conjugate, you're going to FOIL out only the conjugate pair, that's in the numerator here, and not the non-conjugate pair, that's the denominator. FOILing the numerator, sec y times sec y is sec squared of y. That's the first. Outside, sec y times a positive 1 is a positive sec y. Inside, negative 1 times sec y is a negative sec y. And last, negative 1 times a positive 1 is a negative 1. The secant y's will be able to cancel. The outside and inside terms are always same value, opposite sign after a conjugate FOIL. The denominator, those are not conjugates, so I will not FOIL those. And I will just leave them multiplying each other. Now, the numerator has a difference of squares, and it could factor, but you don't want to do that because that'll return you to your original form. It also has a Pythagorean trig identity. That is what we're going to want to use. We have 0 over 0 occurring here, and in the denominator, the 0 is not coming from that. It's coming from that. And we therefore need to cancel a tangent out, and that's going to be by making use of the Pythagorean trig identity. Tan squared plus 1 equals secant squared. Now we need to solve for secant squared minus 1, since that's what we have in our expression. So we can subtract the 1 to the right side. And secant squared minus 1 is actually equal to tangent squared, and that numerator can be replaced with tangent squared of y. Now tangent of 0 is 0, and so we still have 0 over 0. We haven't eliminated that just yet, but we now have matching factors that can cancel. We have 1 in the denominator and 2 of them in the numerator, so we're going to be left over with 1 of them in the numerator. But by canceling that out, we should no longer have the 0 over 0 indeterminate form. And I'm just going to rewrite exactly what we have left over. Our next step will be to replace each of the y's with a 0, tangent of 0 over the secant of 0 plus 1, tangent of 0, sine of 0, which is a 0, over the cosine of 0, which is a 1. 0 over 1 is a 0. Over the secant of 0, 1 over the cosine of 0, 1 over 1, which is 1, plus 1. We have 0 over 1 plus 1, which is a 2. A 0 over any non-zero number is equal to 0.